Hospitals have a different layout. What is that layout? What is the layout that the hospitals follow, which is actually not a product layout? Hospitals follow what is called as a process layout. Now we have seen example of process layout earlier. Process layout essentially means collection of all the processing departments. Okay, collection of all the processing departments. What do I mean by that? All the machines which are performing a particular process are grouped together in a process layout. Where have we seen this earlier? All the machines which perform a similar type of job are put together. They are not put in the sequence of operations. So here we are saying all the machines which are doing one particular type of job. For example, if you are doing milling operations, all the milling machines will be kept together. If you are doing drilling together, all the drilling machines will be kept together. Unlike the product layout, in a product layout, the sequence is governed by the sequence of operation. The sequence of machines is governed by the sequence of operation. Here I won't do that. In the process layout, what I will do is, I will have a milling department which will house 1, 2 or 3 milling machines. And then I will have a lathe department which will house some of the turning machines. Then I will have drilling machines which will have some drilling centers. Right? And now if the product requires processing on the milling machine and then on lathe and then on drilling machine, it will go from this department to this department to this department and then go out. Okay. Now if there is another product which requires lathe machine first and then drilling machine and then milling machine and then go out, that is also possible in the same layout. Okay. So where have we seen this layout? Let me have that question answered first. Remember when we spoke about academic institute? Removed it, right here. Academic institute. All the CS courses are offered in this building. All the CE courses are offered in this building. All the EE courses are offered in this building, which is a process layout, which is actually a process layout. The earlier example of healthcare facility that I spoke about, right? If it is a proper hospital, how are the hospitals arranged? In every hospital, you will see a gynecology department and you will see a pediatric department, right? What happens there? All the gynacs, all the people who have a particular specialization, they have their offices in a similar area. So that is the gynecology department, right? Somewhere you will have an oncology department, right? Somewhere you will have an ophthalmology department where all the eye surgeons are sitting. Somewhere you will have a pediatric department. So all the experts in pediatrics are sitting in one place, which is very different from product layout. Product layout is the arrangement based on a sequence of operation. Here you don't care about the sequence of operation. Here you are saying that all my pediatric specialists will sit together, all my oncology specialists will sit together, all my computer science faculty will sit together, all my electrical engineering faculty will sit together. So we are talking about not a product layout, but we are talking about what is called as a process layout. Okay, process layout. So collection of processing departments. So it is a collection. All my milling machine collected together, all my drilling machine kept together, all my turning machines kept together. Okay. So this process layout is needed when your volumes are low, but the variety is quite large. Okay. So there is a classic two-dimensional diagram that we generally draw. Let me draw that for you. So this is the volume and this is the variety. Okay. Now, for example, take what example do we take? Let us take typical manufacturing example from where all these product layouts and all initiated. Let us take manufacturing example, in particular manufacturing of cars. Now, one particular facility, right? Suzuki, Tata, doesn't matter, Honda, Toyota. How many cars do they have? Right? How many types of cars do they have? I mean, how many cars do they have is a wrong question. They manufacture thousands of cars, hundreds of thousands of cars, right? But I'm talking about how many models do they have, right? You can think of Honda as Honda City and Honda Jazz, right? I don't know, CRV, Honda CRV. So the variety is not very large, but the volumes are quite large. As I said, how many cars do they make? They make hundreds of thousands of cars. So volumes are large, variety is small, right? Volumes are large, variety is small, and that is when you use product layout. So on this so when the volumes are quite large and the variety is quite small, as in the Honda example, organizations usually follow product layout, which is why we have assembly lines for manufacturing cars. Let us take an example on the other end of the spectrum, which is going to be here, where the variety is quite large and the volumes are quite low. Good example of this, let me take an example of an academic institute, and why go that far? Let me take an example of IIT Madras. At IIT Madras, students have a lot of flexibility in their curriculum. So a student can choose that I am going to take this elective from mechanical engineering department, some other elective. So the student may be from mechanical engineering department, and the student is saying, let me take this elective from mechanical engineering department, let me take this elective from computer science department, let me take another elective from metallurgy department. Another student decides her own path, saying that I am also from mechanical engineering department, but I am going to take an elective from biotech department, I am going to take an elective from management studies department, I am going to take another elective from civil engineering department. So every student chooses her own path. Since every chooses student her own path, the combination of electives are, the variety is quite large. The variety is very large. However, since all the students choose their own path, the students having similar type of electives is actually quite small, because what is the probability that I have chosen the same 3 electives that you have chosen, right? So what is the probability that our paths are exactly similar? Very low probability. So the volumes in each variety are quite low. Okay, so this is an example of very high variety, because students choose their own path of what electives to credit, which department to credit them in. But the students of similar type are actually smaller, and therefore they go for process layout. And that is why we said earlier, the earlier layout that I had described on the first slide, it said that academic institutes usually have a faculty of civil engineering sitting together. Courses in computer science are offered in the computer science building. Courses in electrical engineering departments are offered in the electrical engineering building. So that's a process layout, because the products that are flowing, right? Products are students crediting a course here, and then course here, and then course here, and then going back to the hostel, right? So the products are of all varieties. So the products choose their own path, right? So let me take you back to the first slide. Let me build it again, no problems. So here, let us say that there is this academic institute, and here is my mechanical engineering department, here is my so this is my ME, this is my EE, this is my CS, and this is my MM, metallurgy and material science. This is my management studies department. Now one student may choose to take one elective from mechanical engineering, one elective from electrical engineering, one elective from management studies department, and go back to hostel. The other student may choose the first elective from MM department, then CS department, then MS department, and then out, right? The third student may have completely different choices, and therefore she chooses one course from electrical, one course from computer science, one course from mechanical engineering, and then goes out. So every student follows their own path. since the variety is quite large, if you were to build a product layout for this, you will actually have to build so many product layouts. The variety is quite large, as I said. For every variety, you will have to build a product layout, right? That is not possible. That is not possible, and therefore the best possible layout, or the probable, even why even say optimality, the most feasible layout is a process layout. Okay, so that's your process layout, typically used when the volumes are low and the variety is quite large. So these two choices are very clear. When the volume is quite large and the variety is quite small, go for product layout. When the variety is quite large, the volumes are quite low, go for process layout. Now, what are we going to do if we had this case where the volume is also quite large, the variety is also quite large? Or what am I going to do when the volumes are low and the variety is also low, right? So let's not worry about these two question marks. I wanted to establish the difference between product layout and process layout, and this is the essential difference between product layout and process layout. High volume, low variety against low volume, high variety. Okay. So whenever there are rapid changes in the product design, and every time you change the design, if you are in product layout, you will have to change the layout, right? So therefore product layout is not even feasible. So the only thing feasible is what is called as a process layout. The best example of that is a job shop. Now, what is a job shop? Okay, let us say that there is a contract manufacturer. This contract manufacturer has some machines, and using those machines, the contract manufacturer says, I will take all kinds of contracts. Now, the contract may be from automobile industry to manufacture one particular part, one particular spare part of a car. The contract may be for manufacturing a steel part that is required in the construction industry, probably a small plate or a small beam or something like that. Some processing required, right? So this contract manufacturer may accept contracts from multiple types of organizations or multiple products. To sustain the business, they will have multiple such contracts going on at the same time. Now, each product that they have to contractually supply has its own design, has its own processing requirements, and therefore has its own path. What is the path? This is the path, right? This is the path. All these are paths. So depending on the variety that this contract manufacturer is actually processing in their factory right now, every product will have their own path, and there will be multiple such paths. Since this guy is a contract manufacturer, it doesn't make sense for this person to have an assembly line. It doesn't make sense for this person to have a product layout, because every contract may be different. Now, every new contract comes, this person cannot rearrange the machines and put them in a sequence. Therefore, the best possible layout is actually the process layout. So that's your process layout, and that's how we have examples, right? So I have given you Honda example, I have given you an academic institute example. So once again, just to convince you that all these layouts are equally relevant in service industry as they are relevant in manufacturing industry. Alright, so how does a process layout look like? Process layout, so this is your milling shop, right? This is your milling shop, this is your drilling shop, this is your lathe shop, right? This is your paint shop, right? So one product may start in sewing, then go to lathe, and then go to milling shop, right? And probably then goes to drilling shop, and then after that it goes to assembly. Second product may start with grinding shop, and then it goes to lathe. Sometimes it skips lathe and goes to milling shop, right? So you will realize that look at the arrows. Look at the arrows. The arrows are not in one direction. The arrows are haphazard, right? So one product here goes, completes the milling and then goes to drilling. After drilling, they may go to paint shop, they may go to assembly shop, right? So it's not unilateral direction, very simple direction that we had in the product layout. These arrows are actually much more complicated because we are allowing each product to have its own path. So this is a process layout. Okay, let me summarize the process layout by listing out the advantages and disadvantages. So what are the advantages of process layout? The biggest advantage of process layout is utilization. is utilization. Now remember, in the product layout we said, if a product requires a lathe machine, a milling machine, a drilling machine, a sawing machine, a milling machine and a paint shop, we will have to invest in 2 milling machines because the sequence of operation requires 2 milling operations. In process layout, we may get done with only 1 milling machine and saying that, well, I will have a milling shop, I will have a lathe shop, I will have a drilling shop, I will have a saw machine. So the product will start in a lathe shop, goes to milling machine, goes to drilling machine, goes to sawing machine, comes back to milling machine and goes out. Right. So a product can create its own path visiting the milling shop twice. So therefore, I don't have to invest in 2 milling machines. I can invest in 1 milling machine. The processing time may the total production time may go up, because this the product may have to wait because there is other processing going on at that time. But in general, I may have better utilization of the machine, right? Better utilization of the machine, and therefore fewer machines may be required. Biggest advantage of process layout. Secondly, immense flexibility, huge flexibility in the process layout. Unlike product layout is for that particular product. That's why it is called a product layout. You change the design of the product, the sequence of operation will change. I will have to come up with a new assembly line. Won't happen in a process layout. Therefore, you change the product layout, you change the product design. I don't care. Process layout is not going to change, right? So, process layout offers a very high degree of flexibility because the milling shop process is only milling operation. Drilling shop process is only drilling operation. So you bring in any product, I don't care. The product variety may be quite large. I don't care. I'm just here to mill. I'm just here to turn. I'm just here to drill. Right. So the computer science faculty says, I don't care whether the student comes from mechanical engineering department or electrical engineering department. I'm here to offer cryptography course. I will teach cryptography. Right. So therefore, huge flexibility exists. As I said earlier, I may not have to invest in multiple machines. Therefore, the investments, the capital investments may be lesser than what they are for the product layout. And because of the flexibility, the diversity of the tasks that can be processed is really, really large. And therefore, it becomes more interesting and satisfying for the operator. In the product layout, the operator is working on single product, right? Here, the operator may see different variety of products, because here the variety is quite large, and therefore the total job content of the operator becomes much more interesting, much more satisfying, because they are working on different products, different contracts. Remember the contract manufacturer, and therefore very specialized supervision is required. Unlike common supervision required for the product layout, process layout requires a very specialized supervision. Alright. Now that we have listed the advantages of process layout, let us list out the disadvantages of process layout. Disadvantages of process layout. What is the biggest disadvantage of process layout? Students have to travel from computer science department to mechanical engineering department to electrical engineering department, right? They have to keep traveling. So the total travel, right? The total travels are going to be longer. So material handling is going to be much more expensive. Remember that we are probably talking about conveyor belts, we are talking about forklifts. So those expenses will go up, right? Because they have much longer flow lines. Unlike product layout. What happened in product layout? In product layout, the output of one machine directly feeds into the second machine, located right next to each other. So the material handling was much less, the work in process inventory was much less. Here in process layout, that will be larger. Secondly, this is not as simple. Remember the flow, remember the arrows that you saw? They are all over the place. Right? They are all over the place. Therefore, the production planning and control actually is little complicated. Actually, it's a lot complicated. Okay. So, production planning and control systems are actually much more complicated. Because the products flow over a longer distance, they travel longer distances, they spend a lot of time traveling, they may have to wait for the machines, and therefore the total production time is usually longer or usually higher in case of process layout than it is for the product layout. Product layout is a very specialized layout for that particular product. Since this is a generic layout, the total time required is usually longer. Okay, since I am going to use forklift and I may have to go from one department to the other department, usually those movements are not going to happen one at a time. So I may have to batch them and then move them, and therefore the work in process inventory is actually higher because I am not going to move one product from this milling shop to the drilling shop. I am going to wait for 10 products to get finished and then move those 10 products to the drilling shop, and therefore the work in process inventory actually grows in a process layout compared to the product layout. Obviously, the space and capital is tied up in this work in process inventory. A lot of space is required because in general the inventory is higher. The temporary storage space will have to be provided. All that will actually increase the space requirements, and it may actually tie up your capital because your inventory is locked up. Okay. Now earlier we said that the job becomes interesting for the operator. Right? The job becomes interesting for the operator because they are actually seeing variety of products flowing through. Since they are seeing variety of products flowing through, right, they actually require higher grades of skill, right? Because in the product layout they see one type of product. I know I have to perform milling machine or I have to use milling machine on this one single product throughout the day, right? It becomes a very repetitive job, and therefore people get highly skilled very quickly in that job. If they are shown a different product, they cannot process because they have been processing only one type of product. Here in the process layout, the operator is working on all variety of products. They may be a milling machine operator, but they are working on all variety of products, and therefore their skill requirements are much higher because they should be able to process product A, product B, product C, product D, because it is quite likely that they will see all these ABCD products on the same day, unlike the product layout. Okay, so those are some of the disadvantages of the process layout. I hope the process layout is clearer now. Okay, let's go to the third type of layout, which is called group technology layout, or simply called group layout. The complete name is group technology layout. Actually, I'm sorry, I was being lazy. I just typed group layout. Correct name is group technology layout. What is group technology layout? Product layout is for a single product. Now, what if I expand that definition little bit and then say that I will combine similar designs together, and then I will create a group of products, and for that group of products I will design a product layout. So I will design a product layout, kind of a layout, but it is not for a single product, it is for a group of products where I will allow some deviation in the sequence of operation. Right? There are many such examples in the automobile industry where multiple models are now getting manufactured on the same assembly line. Okay, so it's a product layout, kind of a layout, but it is not for a single product. Multiple types of products, multiple models are getting processed, but what will happen is I will have this operation fixed, right? I will have a lathe machine, I will have a milling machine, I will have a drilling machine, I will have a grinding machine, and product 1, so product A, will go from lathe to milling machine to drilling machine to grinding machine and then to the paint shop. Now I will allow another product, right? Another product, product B will also start with lathe. It will go to milling machine. It doesn't require a lathe, drilling machine. It will go to grinding machine. It will go to paint shop, and it will go out. So I am not having the same sequence of operations, but I will not allow too much deviation also. So now I have a single line on which I am able to process multiple products, but the main requirement is in terms of design, product A and product B should be similar. They should be grouped, right? So we should be able to form groups of products which can be processed on a similar product layout, kind of a layout. It's product layout, kind of a layout. It's not exactly product layout. It's not exactly process layout either. It's somewhere in between. Okay, so when we don't have enough volumes to justify a product layout, we can't go for a complete product layout. So I will allow some flexibility, but groups of products will move, not individual products, right? So by grouping products into logical families, a product layout can be justified for this family now, as that's what I was saying, right? And these groups are essentially called cells, in particular manufacturing cells, and therefore group technology layout is also called cellular layout. Okay. Once again, just like process layout, even the group technology layout has very high degree of intra-departmental flow, right? Just like product layout, there is a very high degree of intra-departmental flow. How does it look like? So, as I said earlier, cellular layout is a compromise between product layout and process layout. So, how does it look like? This is how it looks like. Okay. So, here this is family A, this is family B. Now, for family A, this is the group, this is the manufacturing cell. For family B, family of product B, this is the manufacturing cell. Now look at the layout. There is a saw machine, there is a lathe machine, there is a milling machine, there is a drilling machine, there is a paint shop. Now for this cell, right, some products may go to saw machine, then to lathe machine, then to milling machine, then to drilling machine, right, and then go to assembly. Or they also have a little bit of flexibility. They can start with saw machine, then go to skip the lathe machine, go to milling machine, then go to drilling machine, then go to assembly. Even further, there may be some products which start with saw machine, then it goes to milling machine, from milling machine it goes to drilling machine, from drilling machine it goes to paint shop, and then assembly. So here there is some flexibility. Each product can choose its own path, but those paths are still not as varied as they were in the process layout. But there is definitely more flexibility for the product, much more than the product layout. So that's why we were saying that group technology layout or cellular layout is somewhere between product layout and process layout. Alright, so this is how it looks like. What are the advantages and disadvantages of group technology layout? Advantages, let us list out advantages. Just like process layout, this definitely increases the utilization of the machines. This definitely builds a team attitude, because now you are not asking the worker to work on a single product. Now workers are grouped together also based on the group of families of the products. Since it is a compromise between product layout and process layout, so all the advantages of product layout, all the advantages of process layout will get associated with the group technology layout. This will actually hurt you also in the disadvantages, but that we will discuss later. Usually it supports some more general purpose equipment, not like a special purpose equipment that is required for product layout. For product layout, we require a very specialized equipment that is used only for that product. Here we are talking about family of product, and therefore the equipment has to be much more generic purpose. Okay. However, since you saw the layout, this does not have too much of travel like it used to have in the process layout. So the travel distances are much smaller compared to process layout. Some of the limitations or disadvantages of group technology layout. The problem is the supervision cannot be specific. It can only be generic. Therefore, very high skills are required for the employees than they are required for the product layout, because now the operators are actually processing a family of products. They are not processing a single product. They are processing a family of products. As I said earlier, since cellular technology layout or cellular layout or group technology layout, since it's a combination of product layout and process layout, all the limitations of product layout, all the limitations of process layout will also be associated with the GT layout. Okay, cellular layout depends a lot on a very balanced material flow through the cells. Okay, if the jobs are not balanced, if the work content is not balanced, then the work in process inventory will actually be very large. Sometimes The machines may starve. I will talk about what do I mean by machine starving. A lot of buffers may be required to be kept so that the machines don't starve, right? So a lot of things have to be managed so that the cells function smoothly. Okay, the next disadvantage is it actually has lesser utilization compared to the process layout. It definitely has more utilization compared to the product layout. It has less utilization compared to the process layout. Alright, so that is all about group technology layout. Group technology layout is somewhere between product layout and process layout. Alright, now let us go to the fourth layout. We have seen product layout, we have seen process layout, and we have seen combination of product layout and process layout, which is a group technology layout or cellular